another Universe Sandbox 2 video. Today, I actually have some good news for you. I'm actually starting to work on my next size comparison. So, if you haven't seen it, I'll probably... I'll put the link in the description. But yeah, it is the best video I've ever made on the channel so far. It's literally just a size comparison from the smallest to the biggest things like that I can make in this game. So stars, galaxies, all that good stuff. But anyways, yeah, I'll leave the links in the description. I've started working on my 2017 one, so yeah, that'll probably come out in like March, because with all the research I have to do to like get all the sizes of everything correct and stuff, because I got to add loads of like custom-made objects in. Yeah, it takes a while, so I've got to do my research. But anyways, enough of that. Today we are going to be swapping the orbits of the planets around. So we're going to put every planet in like Mercury's orbit, Venus's, Mars, all the way up to Neptune. Because like, yeah, if we go further, it's just going to be pitch black, so we can't really see much. Maybe we'll do Eris as well, which is a dwarf planet. But anyways, let's start off right here. So we want to go to Mercury's orbit, and let's pretty much add Neptune. And in fact, actually, what we can do is we'll add Neptune here, then Uranus, then Saturn, Jupiter, and then we'll go all the way up to Mercury. So basically inverting the orbit. So Neptune swaps with Mercury, Venus swaps with Uranus, Saturn swaps with Earth, and all that stuff. So yeah, let's do that. That's a pretty cool idea. Right, so let's just put Neptune about... Yeah, that's about right. Can't get it exactly right, because that's just going to take forever. But yeah, so Neptune's there. Let's go Uranus in Venus's orbit. It's going to be really interesting to see what happens here. Then Saturn in Earth's orbit. And we're probably going to see the orbits change a lot as well. That's why I don't want to go Uranus. Right, Jupiter there. So basically we swap the inner planets and the outer planets around. That's going to be very weird. But anyways, Mars, Earth is going to be very cold then. Right. And there we go. And Mercury gets swapped with Neptune, and boom. Perfect. So now, wait, is Mercury placed? Alright, let's delete Neptune, delete Uranus. Saturn's got to go. Let's delete the original Jupiter, Mars, Earth, Venus, and where's the Mercury? There's Mercury, and boom. Right, so these guys are all in orbit now. Are they? Please? Right. Oh, they are. Alright, perfect. So we swapped the orbits. This is really cool. I can't believe I've never thought of this. So this would be Saturn, Uranus is there, and Neptune would be here. So first of all, let's go see Mercury. How cold is it at Mercury? Well, it's very dark as well. Wow. Still 176, but yeah, if we hit play, it's going to cool down very quickly. Come on, where's it? Right, we're going about 19 days a second, so the temperature is taking a massive beating. So let's go straight to 0. And yeah, look at that temperature drop. Oh my god. So as Mercury is out in the far areas like this, maybe it will meet in, maybe go into some clouds of water, maybe. So over time, it probably will become an ice ball like this. In fact, actually, there's a rumour that there is water on Mercury, but it evaporates into water in the daytime, and then at night time it goes back onto the surface. But yeah, I don't know if that's true or not, so someone correct me on that in the comments, please. But yeah, there's rumours that there could be water on Mercury. So basically, we got like a little icy Mercury here. So we're at minus 50 degrees now. Yeah, so yeah, there's a bit of water. Yeah, so it'd probably be something like this. Maybe it's just very cold here, and because it's not hot anymore, the water won't evaporate. So yeah, the water is now permanently stuck on the surface. Yeah, I don't know if that's true though, so yeah, someone correct me on that if they know. Does Mercury, I think it does have some sort of like, yeah, I'm pretty sure someone said it, or I've definitely heard from somewhere that it had water on it. Anyway, let's check out Venus. Oh, we're already at minus 118. Yeah, Venus will still be pretty warm because it still has its atmosphere, which keeps the heat trapped in, but yeah, still pretty cold. And maybe, one thing I actually do believe is Venus's clouds actually came from evaporating water. So now there's no more heat. The clouds will condense back to a liquid. So maybe we'll get water. Maybe, I don't know. Maybe it look like this. It'd just be frozen. Obviously, the atmosphere. Maybe the atmosphere would disappear. Maybe it'd look a little more Earth-like. I don't know. These are all just rumours, I guess. But yeah. If Venus's clouds do contain some sort of water, because they think it was like evaporating water it formed Venus's clouds, but if it's going to go away from the sun, the clouds will obviously condense back to a liquid, so all the water will rain down onto the surface and freeze like this. So I guess that makes sense. I don't know, like, is it? Am I doing it right? Like, oh wow, Earth's frozen. Yeah, but am I doing it right? Like, is this good? Right. Yeah. So Earth is a complete snowball right now. We don't need to add water to this. It's pretty much We don't need to touch Mars either, because Mars is already cold anyway, so it won't really pick up any water. But I think they think there's water on Mars, but Mars will pretty much stay the same. But yeah, don't know why all the cities are still here. Maybe we could survive at minus 80 every day. I have no clue, but Yeah, north to south, just the whole Earth is an ice ball. Well, rest in peace everyone on Earth. There's no way everyone's going to survive that. These cities are just a bug in the game, I believe. Yeah, that's the UK, that's where I live. Alright, anyways, let's leave Earth. Let's go to Mars now. So this is where Jupiter usually is. So we're at minus 158 degrees, so that is very cold. Much colder. I think Mars is usually about minus 70 average, I don't know. But Mars is pretty much exactly the same. We don't need to alter it. There's its North Pole with the frozen water, I guess. Yeah, I think it's frozen water there. And South Pole. Wait, let's get the South Pole out here. Let's have a look at it. There it is. There's a little South Pole. Right, there we go. Right, anyways, not much to show about Mars. Right, here's the interesting stuff. Right, so Jupiter is in the orbit of Mars now. So this is what Mars would usually be. So minus 61, so Jupiter has got warmer. Alright. Yeah, we don't really need to look much at the outer planets because they're going to pretty much stay the same appearance. They'll just get a little hotter. Right, or Saturn, this is where Earth usually is. So we are at minus 17 degrees right now. Okay, you could live there. Well, obviously not because it's a gas giant, but if we add Titan, which is a moon of Saturn, I don't know its precise distance, but actually no, we can do this actually. Actions, add moons to planet, and okay, so this is how far they normally would be. So because Saturn is closer to the Sun than it usually is, yeah, because it's closer than it usually is, the Sun will actually steal some of its moons. Okay, here's Titan. Here's the moon I'm interested in. This has an atmosphere, so how hot is it? It's positive, 9 degrees Celsius. Yeah, because this is like it's basically a cold version of Venus. Just basically because it's further out in the solar system than Venus is. All the moons, yeah, all of these moons are evaporating because then they're all getting really hot because they're not usually this close to the Sun. So yeah, we've added the whole Saturn system in. So there we go. So they're all like evaporating and stuff because they're too close to the Sun. And the Sun has stolen some of the moons because the Sun's gravity is stronger here. Anyways, back to Titan. We could probably live here if we can somehow get water on the surface. So if we just remove that, yeah, it's pretty hot right now, and I think its actual colour is like, yeah, I'm pretty sure the surface of Titan is a little more like orangey, like sort of this colour. Wait, yeah, I think the colour of it is like that. Yeah, it's like an orangey yellow sort of colour like that. So if we could add water on here, oh, it's evaporating. That's not good, but yeah, if we could add water like that. Why is it not going to liquid? Why are we at minus 40 again? Okay, I don't know what's happened there. Okay, that's very peculiar actually. I don't know what's happened there. But anyways, it was at 10 degrees or 9 degrees. It's split. Yeah, I don't know why it's freezing like that. Wait, what the heck's going on? Wait, what if I remove the water? Wait, if I just remove that again? Wait, what? Oh no, it's increasing again. Okay, that's very weird. Is that a bug? I don't know. If you add water, it seems to get cold in temperature again. Okay, that's very peculiar. I don't know about that. Very strange. That is very, very strange. Why is it getting colder? Anyways, let's just pause it. Let's remove it. And let's just remove some of the water. So, okay, so we'd have something like this. And let's go to 30. Please heat up. Or will it? Oh, come on. Is it going to turn to a liquid? Wait, let's go to 100. That's, yeah, there we go. We can see it's going to. Please turn blue. Okay, it's just disappearing. Okay, there we go. So we would have something like this. So it looks pretty friendly. Like it's just a brown version because the rock on Titan is this sort of colour. I don't know if it's not accurate because it's custom made, but yeah, it's not accurate. But maybe something like that, maybe. Like we could live here. Yeah, because if it's in positive temperature, like if it's above 0, we could. Like Earth's average temperature is about 15 degrees in the game normally. So if we live at about 9, that's only a little bit colder. We could definitely live here. But anyways, enough of that. Let's get out of here. Let's go check out Uranus. So where's the Sun? Oh, there it is. There's Neptune, Uranus. Here we go. 27 degrees. Oh wow, interesting. So we're at 27 degrees right now. So yeah, moons of Uranus. Well, there isn't any. Well, I don't think. Well, let's just add moons to planet as well. Right, so here we go. They're very. Look at that. Because Uranus is on its side, the moon's orbit on its side as well. So yeah, any of these moons colonizable? Miranda 25. Okay. Okay, so all these moons are actually warm enough for us to live on, or they're very hot. Actually, 40 degrees. That is very hot. Uranus is a little colder because obviously I think it reflects. Wait, how much? Okay, yeah, these objects absorb a lot more light than Uranus. So Uranus reflects, as you can see there, it says albedo 30. Uranus reflects 30% of the light it receives, and then the other 70 it absorbs. But if we look at the moons, they only reflect 7% of the light they get, and That means they absorb 93% of the light they receive. So that means they get a lot hotter because they're storing a lot more heat. So all of these moons are really, really hot. About these moons, where's the main aerial? It's quite a large one. 17 degrees, yeah, we could live here. If we can somehow colonize this, so if we can somehow make, like, create an atmosphere. So let's add an atmosphere in. Let's just go like that. So we have an atmosphere now. Increasing the temperature a little bit, so it reflects 39%, so it reflects more light than Uranus does. Oh, has it got like... Wait, what the heck? Look, it's got cities! Well, there we go, we colonised it. Look, it's got cities. Oh, that's cool. That's definitely a glitch. It's not going to do that, but there we go. I think I'll save that for the future, actually. Let's just save it as that. Yeah, so we literally have a colonised one. Wait, is it saved? Let's just check. I think it is, isn't it? Okay, there. Is that it? Oh, this is my old one. That's the old one. Where is it? Oh, there's a new one. They look exactly the same. They've got different names. Okay, that makes no sense. But anyways, we've got cities. I don't know why these cities suddenly appeared. That is very strange. I don't think it's because of the atmosphere. But anyways, let's add some water in. Can we add water? Oh. Whoa, whoa, whoa. We don't want to flood. That ain't good. Alright, so if we could colonise a moon of Uranus, we could have something like that, maybe. That's pretty cool. Still got the cities. That's very interesting. We are losing water because, yeah, this object's quite small. But yeah, so it looks like as well. So basically, we could probably do the opposite of this. So while in the future, obviously, we know the sun is going to heat up and get bigger, brighter, more luminous. So maybe we could actually colonize some of these moons and actually live on these outer, or the gas giants' moons. Titania, 30 degrees, a little hot. What about Oberon? 35. Yeah, so they're doable. We could live on these at some point. And Neptune, all right, 140 degrees. So the hottest planet in the solar system now is Neptune. Right, so let's add its moons. Let's see if we can look at Triton. How hot is Triton? So where's Triton? Yeah, the main moon of Neptune. It's actually getting destroyed by the sun. It's evaporating. You can see the little smoke trail coming out the back. Yeah, so it's evaporating. So how hot are you going to be? Okay, so it just goes straight into negative. Oh, but look at this. It reflects 89% of the light it receives. So yeah, this object will always be pretty much cold unless we put it like right next to the sun. So yeah, we can do that. So let's just get another Triton in. Triton. Where is it? Come on. I'll get my normal one. I won't get the custom one. That's my usual object. Where's the normal one? Come on, where's it? Here we go. Let's see how hot it is here. Is it going to heat up into positive temperature? Okay, yes it is. Oh, it's still decreasing though. Okay. Yeah, so it reflects a lot of light. And if you make it reflect 100% of the light, no matter how close we pull it to the sun, it will still be cold. Because if it was reflecting all of the light it receives, it's not absorbing any light, so it will literally always be cold. Okay, so we're this close to the sun. We are getting destroyed because we've gone too close to the sun, so the sun's gravity is tearing us apart. But we are at minus 47 degrees, yeah. If you don't know what the Roche limit, or whatever it is, that's the limit, like how close you can get to an object before it starts to tear you apart. So the Death Stars in Star Wars, they probably would get destroyed. If that was a real life and it was that close to a planet, like, the planet could actually tear it apart. There we go, see, it's getting destroyed because it's too close to the main star. But anyways, so Neptune, yeah, Neptune's way too hot. So, looks like the best places are Uranus and Saturn if we wanted to live in this very peculiar system. But, yeah, look at all the moon's orbits there. So, yeah, poor old Earth is too cold, minus 83. Won't change any of the other things. But anyways, going back to that Roche limit thing, basically, the closer if you get too close to a planet, it will literally tear you apart. So I think there's some simulations here where I can show you. So where is it? There's so many new ones in here. It's so hard to find everything. Where is it? It's the one to do a series. Done that we've shown series. Earth and 8 series. Okay. So look, the closer you are to Earth, the quicker you get torn apart, or you don't get torn apart at all. So we can see here, this little one is getting destroyed the quickest. Then if we go further out, you can see this one's at 334 diameter or radius. This one's at 383, 421, 462, and 476. So this one here isn't even getting destroyed. So if any object gets closer to Earth than this object here, Earth will start to pull it apart. But this one is all by itself. Or this one is far enough away from Earth that Earth will not tear it apart. So if we speed up time, all of those ones will get destroyed. But this one is fine because it's far enough away. But anything that goes closer that has less mass. So you see here, the mass of this object is, so this has the mass of 1% of the moon. I think that's 1%, 0.01. Yeah, so 1.29% of the moon's mass. So and then Earth is obviously the mass of one Earth, which is about 80 moons, I think. How much is it? 81 moons. So you could probably 81's mass of moons would fit in there. I think I'm making sense. Hopefully I am. But anyways, Yeah, so any object, no matter what it is, as long as it's smaller than Earth, Earth will tear it apart. So we could put Mars here, for instance. Mars will get torn up as well. It dragged the little safe one there, but Mars is too close. It's going to get torn apart, and also, it's not just Earth that has a Roche limit. Mars also has a Roche limit, but even though Mars doesn't actually destroy the Earth, Mars's gravity will actually heat up the Earth. So the Earth was actually getting hot, even though Mars hadn't actually hit it. Yeah, so Earth is going to tear that apart. What else we got? So I'll do it again. Let's put what about a Venus? Can Earth destroy a Venus? Let's try. Alright, slow down time as well. I think Earth can destroy a Venus. Can it? Oh no, it can't. They just collide because they have very similar mass. So Earth obviously has the mass of one Earth, but I think Venus has like 80% the mass of Earth. Wait. Yeah, 81% the mass of Earth. So yeah. So Earth's got an extra 0 or 20% mass than Venus does. Anyways, if we put a larger object, let's get Uranus, for instance. Uranus will tear this Earth up to pieces. Because, yeah, Uranus has more mass. The object with more mass will obviously tear up the lower or the smaller objects. Let's put it in orbit. And come on, please, go in orbit. And there we go. Right, so, yeah, Uranus should eventually tear this up, I think. Okay, it's gaining the mass. I think it's because, wait, 1.87 mass. Okay, I don't know why that's happening. Oh, wait, Uranus is getting hot. Yeah, Uranus, I don't know why it crashed into it, but Uranus was hot there. So their tidal heating was heating both objects up. So there's Uranus. But anyways, let's go back to, let's just get Jupiter in, because this is the biggest planet in the solar system, obviously. If we put an Earth here, it will destroy Earth. Okay, it's meant to destroy Earth. I don't know why it's not. It should be destroying Earth. And Earth's getting colder. It should be heating up as well. That makes no sense. Yeah, this isn't me, guys. This is the game playing up. But anyways, what if we move it closer? Try that. Can we move it? I don't know why I'm flipping upside down, but can we move it closer? What about that? Oh yeah, there we go. Yeah. So if you get too close to Jupiter, you will get torn apart. Yeah, we see it's taking the oceans. All the oceans are evaporating because it's the gravity, the tidal heating is heating both objects up. So Jupiter's going to heat up as well. All right, how hot is Earth? What if we make its orbit even smaller? So let's do this. If we pull it even closer, yeah, there we go. If you get too close, Jupiter will shred you apart. Look at all these little objects coming out. And destroyed. Yeah, Earth is finished. Look how close it is. It's literally touching the cloud layer on Jupiter. Oh my god. Look how close it is. Yeah, now Earth has literally just been destroyed, and now it's just an asteroid. Look, literally just an asteroid. Yeah, so poor Earth has made a new ring system for Jupiter. There we go. That's pretty cool. And Jupiter's heat's heated up, but Jupiter eventually, or should cool down eventually. Yeah, there we go. It's cooling down now. Got a few impacts there from all the Earth fragments, but yeah, there we go. Yeah, so if you get too close to any planet, you will eventually get torn up, but unless you're going straight full speed. So the reason why Mars doesn't get destroyed here is because Mars is travelling way too quickly for Earth to destroy it. Like it hits Earth before Earth fully destroys it. But anyways, I think that will do it for this episode. So that's what the Roche limit is. Wait, let me just get, in fact, to be a little more professional, let's actually get the actual definition of what a Roche limit is. So let me just quickly, let's just quickly search it on my phone. Come on, please. Fingerprint scanner, please work. Right, so going on the phone. So my definition was how close you are to a planet. Like if you get too close, you'll get torn apart. But anyways, let's quickly go to, right, so Roche limit. Right, I think that's how you say it. Alright, come on. Oh, Roche limit. So R-O-C-H-E. So, okay, I was right. So the Roche limit, or Roche limit, is the minimum distance to which a large satellite can approach its primary body without being torn apart by tidal forces. So, it also says if they have similar mass or similar composition, they won't get destroyed. Or it's like something like that. I think that's what it said. But anyways, yeah. So Earth is obviously the primary body because it's the largest. It has the largest mass. So if we put a little moon next to it, it will destroy the moon because it has more mass. So there we go. The moon just gets absolutely obliterated. But if we put it somewhere here, it won't because it's not close enough to get torn to shreds. So there we go. We've got a ring system now. Look, we can make an Earth ring system. Because Earth's Roche limit, or Roche limit, or however you want to say it, is tearing apart these smaller objects with less mass. Oh, that was pretty crazy. But there we go. We got a ring system. That's pretty cool. Yeah, that's cool, isn't it? So we can make a ring system just by putting loads of asteroids really close to the Earth. Yes, that's all good. But anyways, I think that'll do it for this video. So we're getting up to 20 minutes now. I don't want to make it too long. But yeah, so if you enjoyed this episode, please leave us or subscribe, hit the like button. And if you have any questions or want to discuss things in the comments below, yeah, feel free to. I'll make sure I reply to you. And yeah, hopefully we can have a good time. But anyways, yeah. So hopefully you all enjoyed swapping the planet orbits and the Roche limits. So let's go quickly check this out. So Venus is going to get shredded to pieces here. So there we go, look. Too close to Jupiter, you get torn to shreds. Look at that, that's mad. And the smaller you are, the more chance you'll get destroyed. So if we try, let's put a planet 9. The gas giant, yeah, that's going to get destroyed. What about Neptune? Can we destroy Neptune? Yeah, we can, it looks like. It hit. Jeez, you can see the fragments there, but yeah, so basically, don't mess with Jupiter. That's what we can conclude today. But anyways, like I said, hopefully everyone enjoyed. Leave a like, subscribe. I've already said this, what am I saying? But anyways, I'll see you in the next video. Goodbye. It is the best video I've ever made on the channel so far. It's literally just a size comparison from the smallest to the biggest things like that I can make in this game. So stars, galaxies, all that good stuff. But anyways, yeah, I'll leave the links in the description. I've started working on my 2017 one, so yeah, that'll probably come out in like March, because with all the research I have to do to like get all the sizes of everything correct and stuff, because I got to add loads of like custom made objects in. Yeah, it takes a while, so I've got to do my research. But anyways, enough of that. Today we are going to be swapping the orbits of the planets around. So we're going to put every planet in like Mercury's orbit, Venus's, Mars, all the way up to Neptune. Because like, yeah, if we go further, it's just going to be pitch black, so we can't really see much. Maybe we'll do Eris as well, which is the dwarf planet. But anyways, let's start off right here. So we want to go to Mercury's orbit, and let's pretty much add Neptune. And in fact, actually, what we can do is we'll Hello everyone, and welcome back to another Universe Sandbox 2 video. Today, I actually have some good news for you. I'm actually starting to work on my next size comparison. So, if you haven't seen it, I'll probably... I'll put the link in the description. But yeah, add Neptune here, then Uranus, then Saturn, Jupiter, and then we'll go all the way up to Mercury. So basically, inverting the orbit. So Neptune swaps with Mercury, Venus swaps with Uranus, Saturn swaps with Earth, and all that stuff. So yeah, let's do that. That's a pretty cool idea. Right, so let's just put Neptune about... Yeah, that's about right. Can't get it exactly right, because that's just going to take forever. But yeah, so Neptune's there. Let's go Uranus in Venus's orbit. It's going to be really interesting to see what happens here. Then Saturn in Earth's orbit. And we're probably going to see the orbits change a lot as well. Why I don't want to go Uranus. Right, Jupiter there. So basically we swap the inner planets and the outer planets around. That's going to be very weird. But anyways, Mars, Earth is going to be very cold then. Right. And there we go. And Mercury gets swapped with Neptune, and boom. Perfect. So now, wait, is Mercury placed? Alright, so let's delete Neptune, delete Uranus, Saturn's got to go.